In this lesson, I'll show you how to approximate the area of a function using midpoints. This is part 2 in the series. The question reads, use the midpoint method to calculate the approximate area under the curve f at x is equal to 3x to the power of 2 from x is equal to 0 to x is equal to 10, taking panels of 2. To make it easier to visualize what they're asking in this question, I'll first show you what the function looks like graphed. They want us to approximate the area from here all the way up here using the midpoint method. Now they tell us that they want us to take panels of 2. This means that we will be creating rectangles that have a width of 2. So our first rectangle will span from 0 to 2 on the horizontal axis, and because it's the midpoint method, we'll actually be taking the middle of each of these rectangles. So pretend that we have this rectangle right here. The middle point is 1, and we will be finding out what the function is when x is equal to 1. So this point right there. And that will represent the rectangle's height. Now because the range is from 0 to 10 and they want us to have a width of 2, 10 divided by 2 is 5. So expect to have 5 rectangles fit within this range of numbers. The next rectangle's midpoint will be at 3. And that will be right there. So we'll have a rectangle that passes through that midpoint. We'll have one at 5. And the midpoint should be right here. We'll have one that passes at 7. And that means our rectangle will span this height, whatever that is, and we'll find what that is soon. Another one at 9, and that's it. That reaches up to here. So we have 5 rectangles, and what we'll be doing is finding the area of each of these rectangles. So length times width plus length times width plus length times width, and so on. First, let's find out what f at x is when x is 1, 3, 5, 7, 9. And our second column will be f at x. Our function is 3x to the power of 2, so these won't be difficult to calculate. 3 times 1 to the power of 2 is 3. 3 times 3 to the power of 2, that's like saying 3 times 9, which is 27. The next one will be 75. Then following that 147, and following that 243. Now remember, the area that we are going to find is just an approximation. It's not the exact thing. In fact, in order to find the exact area underneath this particular curve, we'll integrate this function after this, just to see how accurate we were. Now that I found my outputs for each of these x values, I'm going to multiply these numbers by 2. So this by 2, and so on. Let's see what happens if we do that. I'm going to use my calculator. 3 times 2 plus 27 times 2 plus 75 times 2 plus 147 times 2 plus 243 times 2, and this gives us 990 square units. 990 square units. I'll write down units squared. That is the approximate area using the midpoint method. Let's go ahead and see what would happen if we took the integral of 3x squared between 0 and 10. The integral of 3x to the power of 2 is, we add 1 and divide by 3. We get 3x to the power of 3 over 3, where the 3's cancel out. So we have x to the power of 3 when x is equal to 10, minus x to the power of 3 when x is equal to 0. Obviously this is 0. Now if I substitute x into here, I end up with 10 to the power of 3, which is 1,000 units. 1,000 units squared. So we're off by 10 units. And it turns out that we can obtain a greater accuracy in computing the area under a curve simply by reducing the width of each rectangular panel. In fact, the table that you see on your screen shows this relationship, that if we reduce the width, notice that we have 0.0156 as one of our widths, we end up with an area that is even closer to 1,000. And so there you have it. That is how to approximate the area of a function using midpoints.